Hi everyone, I'm Eren and this is my EE327 project called FlexPedal. The idea is a wireless digital control system for analog guitar effects. My main goal is to keep the sound generation in the analog domain while making control more flexible through digital communication and user interface design. And again, FlexPedal is a wireless control system for analog guitar pedals. So the system uses two boards that communicate wirelessly using ESP32 controllers, microcontrollers. The controller board reads knob positions through its ADC, and it also displays pedal board status. The controller board will also display the turning of the knob and the parameter that it corresponds to on its LED screen. The pedal board receives the control values set by the knobs on the controller board and uses digital potentiometers to adjust analog circuit parameters. So overall, the project is trying to combine analog tone with the convenience and flexibility of digital control. This slide should explain the system architecture a little better. One of the main design choices was using a two-board architecture. This separates the user interface from the actual audio circuitry, which makes the system more modular and also allows flexible controller placement. For example, the controller does not have to physically sit on the pedal board, and this thing is really convenient for guitar players to especially play live, because for you to change the parameters of your guitar effect provided by the pedal, you'd have to get down on the floor and actually tweak the knobs manually, and this is really inconvenient, especially when you're like playing live. So this is a cool feature. Another design choice, obviously I'm using the ESP32 because it already has the built-in wireless capability, and on the controller side it can directly read analog knob positions through its ADC. Another important decision was using digital potentiometers on the pedal board. This allows the pedal board ESP32 to electronically control analog circuit parameters instead of relying on manual knobs. The communication here is bidirectional. So the controller sends control signals to the pedal board, and the pedal board sends switch state feedback back to the controller. So the display reflects the active state. Let me get to the foot switch and I'll explain it better. The foot switch pedal is also a design choice here on the pedal board. This way it still behaves like a traditional pedal because the foot switch directly switches the analog circuitry, and it also reports that state back to the controller. So what I mean by that is that I don't want the pedal board to have only one circuitry for one effect. I want to have multiple circuits for different effects. Like for example, here I said distortion under the analog effect circuitry box. I want to have a distortion circuit, I want to have a reverb circuit, or maybe a fuzz circuit. I haven't decided on the other two yet, but I want to have three different effects in one pedal board, and these foot switches will be able to switch between the analog circuitry corresponding to a specific effect, and the switching will be reported back to the ESP32 through wireless communication. This is the design choices and the overall architecture. Here is my current state. On the right is the Gantt chart, and on the left is the bill of materials. I ordered most of the parts. I would just have to include an LED screen and digital potentiometers. But currently my main goal is to finish this circuitry below. As soon as my parts arrive, I will finish it and test this out. This circuitry is just a distortion effect circuit, and I want to build this circuit and then plug it into an amp and to my guitar to see how good the tone is, and change the parameters on this circuit to get to the tone that I really like. Just so that I can confirm that okay, the analog circuitry works. I can move on to to microcontrollers and microcontrollers controlling digital potentiometers and whatnot. So yeah, this is where I am. As soon as the materials arrive, I'll finish the circuit and have basically a simple effect pedal, um, and then I'll move on from there. So yeah, market research. The target users are guitar users ranging from beginners to professionals, especially live performers and musicians using larger pedal setups. The overall guitar pedal market, it's already large, estimated in the range of about $1 to almost $4 billion in 2025, with projections continuing towards roughly 5 billion over the next several years. This suggests continued demand, especially for multi effects and flexible control systems. Um, in terms of competitors that are like traditional analog pedal brands like Boss, MXR, and Electro Harmonix, digital multi effect systems like Line 6, the Neural DSP, and also MIDI controlled setups. Um, so user interviews. I interviewed two of my friends who play guitar. Um, my friend Matt said that being able to control analog effect parameters from a separate board will be especially convenient during live playing because the controller could be placed wherever it is easiest to access. And my other friend Adam, he's also a great guitar player, said that pedal boards often become physically crowded, so integrating multiple effects into one system could improve efficiency and save some space. So the main feedback themes were convenience, flexibility, and compactness. So something new I learned, although it's pretty basic, is that digital potentiometers exist. I was really I was really surprised to see when I was trying to improve, like basically the difficulty of my project, that something like this existed, and now I can integrate it into my project. So that was pretty cool. So they act as basically electronically controlled versions of normal potentiometers, normal mechanical ones. And instead of moving the Viper by hand, the microcontroller sets it digitally. I also learned, I also looked at some basic specs. Typically, resistance values are in the range of about 5 kilo ohms to 100 kilo ohms, with resolutions from 32 to 1024 steps. They're commonly controlled through SPI or I2C, and they're used in applications like calibration, gain control, sensor trimming, filter tuning, and even wearable or medical devices. So yeah. Something useful. I said maybe next to it because you might be familiar with this. I used the ESP32 for the first time last quarter, so I definitely wasn't. So ESP now is basically a peer-to-peer wireless protocol for ESP devices. It doesn't require a router or a normal Wi-Fi network, which makes it a nice option for direct embedded communication. It supports small packets up to 250 bytes, and it can be used either one way or directionally. For this project, that makes it a good fit because I only need to send relatively small pieces of data like knob values, and the switch states, and I also need two-way communication, so this really helps. So yeah. To finish, I have two questions I like feedback on. I guess the first one is that what other analog effects should I consider adding beyond the initial distortion implementation? Um, if you're familiar with effects, I would just really appreciate the feedback because there are so many different effects that I'm thinking about, and I haven't decided on the other two effects. And for the second question, what part of this project seems most challenging or most worth improving? I'm open to any kind of feedback, and yeah, that was my project. Thank you.